Good morning, everybody. Uh, Today, let's see some of the important and pertinent part of the complex number, namely this 5.4, the modulus and the conjugate of a complex number. Modulus na karino? What does modulus mean, and what stands for? Conjugate of a complex number. Conjugate si karino, modulus si karino ko. Let this be a complex number, then the modulus z denoted by z modulus is defined to be the non-negative real number, that is the root over a square plus b square, that is the z modulus is equal to root over a square plus b square, and the conjugate of z denoted as z bar conjugate. The complex number a minus ib a minus ib, that is z bar, that is equal to a minus ib. For example, 3 plus I say root over say 3 square plus 1 square. Sidaida hiding is a noina hana confused torongani sidaida modulus ne na hiraga a square plus equigi b square na sida daklok chongjalak pase. Chisi modulus equigi Pythagoras theorem gi hypotenuse square is equal to addition of the square of the addition of the two remaining sides, and actually Pythagoras theorem gi magi hypotenuse ki square to go lemoriba side sing square sing it in sinaba falga mani haidana Pythagoras theorem the haidana aduni sigise amana kaino oidoribani amana x oidoribani amana y oidoribani ko argan diagram haina haibadi argan plane and haibadi Cartesian coordinate plane ni dana ko Cartesian coordinate plane kari noi du din noi na hana dagi hauna adum khangma ngamgre ba ko thudonu luru banati ma se Cartesian coordinate plane na haibase aduduna akoina kari haibatare ko masidi sigi phibam je hek lak batargadi kaino duna akoigi Pythagoras theorem pale and have a coin kangadabne ko adu sumai torga manai na hai ada especially z modulus id modulus of be kaino haidana complex number aina sorry sina kaino ni conjugate ne ba adu sina modulus tu ne ba modulus ma sida real number oigedabani negative oibiyaroi madi positive value ha to oigedabane ko haibadi karigumba mafam amagi agoi negative te leibiyadaba number mayam leidana se nakoi namanaba kaya lai na haibada negative ta haiba suya yadi zero bokte habiye imanaba amata lakte na tuna akoi gi human language the mean the way mathematical language na zero na harakpadu akoi gi human language na kaino aitana amata lakte na haiba min do bayai aduga nakoi namanab kya lai haida koi manaba -2 lai -3 lai -4 lai -5 lai na haiba de adegi lyric sigi maman kaya no ka na haibte -20 rupees ni ka na minus is so haiba da ko lamdugi park chawbudu square meter kaya no the square meter 0 bokte haiba park chawbo kaimte leiti na adu lamdugi park chawbudu square meter -20 meter square ne na haiba yadaba haibidi negative ta sunglei leiba yadaba number hana haibani ko admain tawdana ma ngasai gi modulus se complex number gi modulus se masi negative te leiba sunya yaroi na haibani ko aduna conjugate amuk la gana conjugate sina magi marak te leiba sign do kano oina haidi opposite oina plus ki opposite to minus ni minus ki opposite to plus ni haidana admaina haiba adugumba amakak leidana magi negative 2 oi positive oirgadi negative oini negative oirgadi positive 2 oigani haidana admaina haibagumba ama leidana ikhoigi aduni adugi matang duni manasida hairisi ko for example kaino aina sumaina aina hare huji kaino modulus puthora inisi modulus sini ko negative oiba yaroi ma positive oina min tawudawni na sumai haibani babtani ko aduni observe the multiplicative inverse of non-zero complex number z is equal to z is given by z root over minus 1 a is equal to 1 by a plus ib and sumaina is equal to a by a square plus b square and sumaina haire mana id multiplicative inverse ni of non-zero complex number is non-zero di oigedaba complex number do haibadi aikoina sidaida a ga b ga si 0 oidhoki taragadi complex number ma su dum 0 oibe phibum ne multiplying of 0 with any number is equal to 0 na dumain toroga leibani na koina chima b siga b sina 0 oithoki taragadi I si sumangi doini aduna ni mana nan 0 na hairakpa language ama torei si karmain toroga ma si multiplicative inverse puthokadege haibo wafam duni ama silai si ko aduna aikoina hana formula ama mamang da pigi dana ko formula p grabani kari formula p gi a plus ib sumaina a plus ib si karmain toraga magi multiplicative inverse pude multiplicative inverse na hai taragadi root z root over z to the power minus 1 ni dana hai di denominator de legene any number oidoi complex number to z na represent tawrabani na any number of z should be divided by z having that is equal to 1 multiplicative inverse and haisina kaino na haibada mabanigi kaino tawudu multiply and hairasu yare aduga divide and divide to quotient 1 tagadabani haibo famni aduga multiplicative and multiply gi mong the sense am lai sidi karigino haibada aikoina 5 by 5 se kaino na haibe yadro 5 into 1 by 5 ana adudi into gi form da leidana adumaina divide gi form do mana into gi form da establish torok pai wani ha 5 by 5 se kamai haibe yaiba 5 into 1 by 5 ana haibe yadro sumain toraga mana multiply gi form da thamak paneba aseng bodi divide neba ko numerator denominator leibani na aduna aroi bada tar isi kari no na hai bada e by a square plus b square na sumain toraga tari ko ma semba horai ni magi formation ma leiba mong do akoina hojik to bo hore ko z inverse ki aduga plus I na sumai hare aduga minus b si logane na sai formula ma mathak ta pan gi budu kaudi ko adugi formula da ma si apply torok ne ba ko kada wai da pan gre ko multiplicative inverse ko kawai da palli sida palle ko sidaida the existence of multiplicative inverse si leiribra leitabra na haibagi mase exist oibra oidabra na haibasigi magi chang yeng amakhak sida leirisi for every non-zero complex number 0 di oiba yadre na haibani ko 0 gi di khanagumsi non complex number z is equal to a plus ib or a plus bi ani si manungda ameti ibi hemni ko I si either coefficient oini igera aduga base do oini igera ani do dum iningba ibi maramdi because there is multiplication in between the two number I and b makhoi gi marakta multiplication leiba maramna 3 into 2 haiba 2 into 3 haiba ani si answer chap manaridana aduna mong hongdoga ibidi kemta kaiba leiti haiba wani ko adu a su 0 ga manaba yaroi b su 0 ga manaba yaroi karigumbada managiba taraga di zero complex number ni haiba wafum ama lakadoi ko aduna we have the complex number si complex number si laini to ko ngasai khoina to gibudu sida laidana ko a by a square plus b square si this is the what is this and haitaragadi this is a preparation or this is an expression of preparation of finding modulus haitareko modulus puto omdai gi ekhoi thorang to sem saba karigamba mathematical expression amakhakni haiba wafum ni mana masing matang se haise ko a by a square plus b square plus I minus b by a square plus b square sumain doraga haigani haidana mana hairakpani ko sigi plus se dum lay aduga numerator gi kaino du di number du di sign du change tawi ma negative thamai ko negative thamai si plus b haide ko minus b na sumain doraga thami sigi form se ko buyadi either if here is coming minus here to the sign over here should be here ko whatever here will be here nebo ko adu but the thing that you are going to write over here the sign of that particular number should be minus haibani cd cbd minus oidna adum laikani haibo phumni ko denoted by 1 by z and man hairisi id denominator to labor number se numerator denominator form the iraga multiply ne na aroibada muksu lakpi yedana aduna ni 1 by z and hairisi that is equal to kaino sina base sina makhada leba base sina kaino da denominator to labor base na numerator ki base oige na haitaragadi there will be a little bit change in the sign of the power of the particular base what's over here if there is nothing we suppose there is plus 1 and hydra the plus 1 sina plus 1 is the power and hydra lay whenever it changes from the denominator to numerator the sign will be negative oirakaneba adu negative mathanda di ibiyadam dina minus 1 and hairakpani si makhada layringai da plus 1 lay mathakta lay rakanda minus 1 ni ko id denominator gi form the idre numerator gi form the ire hebo form ni ko call the multiplicative inverse ni haidana object ni success sumai to buni na haibani mana matang sida z into 1 by z equal to 1 ni the multiplicative identity sibu kari kawi ekhoina is called the multiplicative inverse of z ne sibu multiplicative inverse kawi haidana haibadi asengmadi 1 tabaduni dana z into 1 by z ke multiply tawraga 1 tai multiply haiba wani divide neba ko aidi masana masada yenba wafum ni haiba wani aduga magi process is main tawni sidaida kidang ngakpa akoigi confuse tawgadaba chamamnagadaba kari makhra leibadu sigi wafum sineba ko sida sign the negative line haibadu don't forget that one aduni applying that one over here we are going to find the canonical akoigi canoni conjugate to puthorakadoini conjugate puthorakpada sumaina tawi haidana mana ama hairakpani ko moini si multiply torok matamda su sumai torina sigi ngasai lagbu process du dum khangi dana ko sina ko amana z bar ne na haitardi sidaida negative leibadu ko positive oigadaba positive leibadu negative oigadaba bar haibada ko bar yaudabaduna karambano si bar yawbusi negative yawramasine ko aduga bar yawbadudi positive oitare masida negative ngaktu oiraga leini haingai leiti haibo phumni ko sigi sidi adi multiplicative inverse to gi kano wafum natti haibo wani ko observe the multiplicative inverse of non-zero complex number that is given by si uji haire ko okay si bo idea leri ko ꯁꯤꯗꯤ ꯉꯁꯥꯏ ꯃꯜꯇꯤꯄ꯭ꯂꯤꯀꯦꯇꯤꯚ ꯏꯟꯚꯔꯁ ꯄꯨꯊꯣꯛꯄꯒꯤ ꯃꯥꯒꯤ ꯐꯣꯝꯗꯣ ꯑꯗꯨꯝ ꯂꯩ ꯁꯤꯒꯤ ꯄ꯭ꯂꯁꯇꯣ ꯃꯥꯏ ꯃꯃꯥꯡꯗꯁꯨ ꯑꯗꯨꯝ ꯂꯩꯔꯝꯒꯅꯤ ꯀꯣ ꯑꯗꯨꯒ ꯁꯤꯒꯤ ꯃꯥꯏꯅꯁꯁꯤꯗꯤ ꯃꯥꯏ ꯐꯣꯝꯂꯥꯒꯤ ꯂꯥꯛꯆꯕꯅꯤ ꯍꯥꯏꯕꯁꯤꯃ ꯑꯩꯈꯣꯏꯅ ꯀꯥꯎꯕ ꯌꯥꯗ꯭ꯔꯦ ꯀꯣ ꯁꯤꯒꯤ ꯃꯥꯏꯅꯁꯁꯦ ꯃꯁꯥꯒꯤ ꯂꯥꯛꯆꯕꯅꯤ ꯍꯥꯏꯕꯁꯦ ꯀꯣ ꯑꯗꯨꯅ ꯁꯤꯒꯤ ꯐꯣꯝꯗ ꯇꯥꯔꯛꯑꯅꯤ ꯍꯥꯏꯕ ꯋꯥꯅꯤ ꯀꯣ ꯁꯤꯒꯤ ꯐꯣꯝꯗ ꯁꯣꯏꯗꯅ ꯇꯥꯔꯛꯑꯅꯤ ꯍꯥꯏꯗꯅ ꯑꯗꯨꯅ ꯑꯔꯣꯏꯕꯗꯗꯤ ꯁꯤꯁꯦ ꯑꯃꯨꯛꯀ ꯁꯨꯃꯥꯏꯅ ꯏꯕ ꯌꯥꯏ ꯍꯥꯏꯗꯅ ꯀꯣ ꯍꯥꯏꯗꯤ ꯖꯦꯠ ꯕꯥꯔꯗꯨꯒꯤ ꯍꯣꯜ ꯁ꯭ꯀ꯭ꯋꯦꯔꯅꯤ ꯍꯥꯏꯕꯗꯤ ꯅꯟ ꯅꯦꯒꯦꯇꯤꯚ ꯑꯣꯏꯗ꯭ꯔꯦ ꯍꯥꯏꯕ ꯋꯥꯐꯝꯅꯤ ꯑꯣꯔ ꯁꯨꯃꯥꯏꯅ ꯇꯧꯔꯒ ꯏꯕꯁꯨ ꯌꯥꯏ ꯁꯤꯒꯤ ꯃꯑꯣꯡꯗꯁꯨ ꯐꯔꯗꯔ ꯃꯣꯁ ꯗ ꯐꯣꯂꯣꯋꯤꯡ ꯔꯤꯖꯜꯠ ꯀꯦꯟ ꯏꯖꯤꯂꯤ ꯕꯤ ꯗꯤꯔꯥꯏꯚ ꯁꯨꯃꯥꯏꯅ ꯇꯧꯗꯅ ꯄꯨꯊꯕ ꯌꯥꯏ ꯐꯣꯔ ꯑꯦꯅꯤ ꯇꯨ ꯀꯝꯄ꯭ꯂꯦꯛꯁ ꯅꯝꯕꯔ ꯁꯤꯁꯦ ꯑꯦꯅꯤ ꯇꯨ ꯀꯝꯄ꯭ꯂꯦꯛꯁ ꯅꯝꯕꯔꯁꯤ ꯁꯨꯃꯥꯏꯅ ꯇꯧꯔꯒ ꯇꯧꯔꯛꯄ ꯌꯥꯏ ꯍꯥꯏꯗꯅ ꯍꯥꯏꯕ ꯃꯇꯥꯡꯁꯨ ꯃꯌꯥꯝ ꯑꯃ ꯂꯩꯔꯦꯀꯣ ꯑꯦꯅꯤꯋꯦ ꯁꯤ ꯁꯨꯝ ꯈꯣꯠꯂꯛꯑꯒ ꯈꯪꯒꯅꯤꯀꯣ ꯍꯥꯏꯐꯦꯠ ꯑꯩꯈꯣꯏꯒꯤ ꯊꯣꯔꯣꯂꯤ ꯃꯥꯒꯤ ꯑꯩꯈꯣꯏꯒꯤ ꯃꯃꯥꯏ ꯇꯥꯊꯣꯛꯄ ꯍꯥꯏꯕ ꯇꯥꯔꯦ ꯃꯃꯥꯏ ꯇꯥꯊꯣꯛꯄꯗꯨꯒꯤ ꯃꯑꯣꯡꯗꯨꯅꯤ ꯀꯣ ꯑꯣꯀே ꯑꯗꯨꯅ ꯐꯥꯏꯟ ꯗ ꯃꯜꯇꯤꯄ꯭ꯂꯤꯀꯦꯇꯤꯚ ꯏꯟꯚꯔꯁ ꯑꯣꯐ ꯃꯥꯅ ꯑꯁꯤꯒꯤ ꯃꯜꯇꯤꯄ꯭ꯂꯤꯀꯦꯇꯤꯚ ꯏꯟꯚꯔꯁ ꯄꯨꯊꯣꯔꯛꯀꯗꯣꯔꯦ ꯍꯧꯖꯤꯛꯀꯤꯁꯦ ꯑꯗꯨ ꯁꯤꯗꯩꯗ ꯅꯦꯒꯦꯇꯤꯚ ꯂꯩꯀꯣ ꯂꯦꯠ ꯑꯁ ꯅꯣꯠ ꯐꯣꯔꯒꯦꯠ ꯗꯦꯠ ꯋꯥꯟ ꯀꯃꯥꯏꯅ ꯂꯥꯛꯀꯦ ꯌꯦꯡꯁꯦꯕꯀꯣ ꯑꯁꯤꯗ ꯅꯦꯒꯦꯇꯤꯚ ꯂꯩꯔꯦ ꯑꯗꯨꯒ z is equal to 2 plus 3i ꯑꯅ ꯍꯥꯏꯔꯦ z square ꯁꯤ ꯁꯨꯃꯥꯏꯅ ꯂꯩꯒꯅꯤ ꯁꯨꯃꯥꯏꯅ ꯂꯩꯅꯤꯅ ꯍꯥꯏꯔꯦ ꯀꯣ therefore the multiplicative inverse of this is given by ꯃꯥꯁꯤ ꯁꯨꯃꯥꯏꯅ ꯄꯤꯔꯅꯤꯅ ꯍꯥꯏꯔꯦ ꯃꯥ ꯉꯁꯥꯏ ꯀꯩꯅꯣ ꯂꯩꯈꯤꯗꯅꯀꯣ what's the sign before here ꯀꯣ originally ꯃꯥꯒꯤ ꯄꯤꯔꯛꯄ what is the original given sign of the particular sign in between the real part and imaginary part of the complex number 하이라게디 this is ꯀꯩꯅꯣꯅꯦꯕ ꯅꯦꯒꯦꯇꯤꯚꯅꯦꯕꯀꯣ ꯅꯦꯒꯦꯇꯤꯚꯁꯤ ꯃꯥꯁꯦ ꯄꯣꯖꯤꯇꯤꯚ ꯏꯔꯛꯏꯁꯤ ꯎꯔꯕꯁꯦ ꯒ꯭ꯌꯥꯟ ꯇꯥꯅꯤꯀꯣ ꯑꯗꯨꯅ ꯀꯩꯅꯣꯗ ꯃꯜꯇꯤꯄ꯭ꯂꯤꯀꯦꯇꯤꯚ ꯏꯟꯚꯔꯁꯁꯤ ꯄꯨꯊꯣꯔꯛꯄꯒꯤ ꯇꯥꯡꯀꯛꯁꯤ ꯍꯦꯛ ꯌꯧꯔꯛꯄ ꯇꯥꯔꯒꯗꯤ ꯁꯥꯏꯟꯗꯣ ꯉꯁꯥꯏ ꯏꯈꯤꯕꯗꯣ ꯅꯦꯒꯦꯇꯤꯚ ꯑꯃ ꯐꯣꯔꯃꯨꯂꯥꯒꯤ ꯂꯥꯛꯆꯕꯅꯦꯅ ꯂꯥꯛꯏꯗꯅ ꯑꯗꯨꯒꯤ ꯂꯥꯛꯆꯕ ꯐꯣꯔꯃꯨꯂꯥꯒꯤ ꯁꯣꯝꯗ ꯂꯥꯛꯆꯕ ꯅꯦꯒꯦꯇꯤꯚꯇꯨꯒ ꯁꯤꯒ ꯊꯦꯡꯒꯥꯏꯅꯔꯒꯅꯤ ꯄꯣꯖꯤꯇꯤꯚ ꯑꯣꯜꯂꯛꯏꯁꯦ ꯍꯥꯏꯕꯅꯤ ꯁꯤꯗꯩꯗ ꯒ꯭ꯌꯥꯟ ꯇꯥꯅꯤꯀꯣ ꯑꯗꯨꯃꯥꯏꯅ ꯇꯧ ꯑꯣꯜꯂꯛꯄꯅꯤ ꯑꯗꯨꯒꯤ ꯇꯦꯛꯅꯤꯀꯦꯜ ꯄ꯭ꯔꯣꯁꯤꯗ꯭ꯌꯨꯔ ꯆꯦꯟꯖ ꯑꯜꯒꯣꯔꯤꯊꯝꯗꯨ ꯁꯨꯃꯥꯏꯅ ꯇꯧꯔꯒ ꯏꯌꯦꯅ ꯍꯥꯏꯕ ꯋꯥꯅꯤꯀꯣ ꯑꯗꯨꯅ ꯐꯥꯏꯅꯦꯜꯂꯤ ꯑꯩꯈꯣꯏꯅ ꯋꯥꯠ ꯋꯤ ꯀꯦꯟ ꯔꯥꯏꯠ ꯑꯣꯚꯔ ꯍꯤꯌꯔ ꯏꯁ ꯗꯤꯁ ꯋꯥꯟ 2/13 plus 3/13i ꯁꯨꯃꯥꯏꯅ the above working can be reproduced the following manner also ꯃꯈꯥꯒꯤ ꯃꯦꯅꯔꯁꯤꯒꯤ ꯃꯑꯣꯡꯗꯁꯨ ꯑꯗꯨꯝ ꯁꯨꯃꯥꯏꯅ ꯇꯧꯔꯒ ꯄꯤꯕ ꯌꯥꯏꯌꯦꯅ ꯀꯣ z inverse that is equal to 1/2 minus 3i is equal to this ꯑꯅ ꯁꯨꯃꯥꯏꯅ ꯇꯧꯔꯒ ꯍꯥꯏꯔꯛꯑꯦ ꯃꯥꯅ ꯃꯈꯥꯒꯤ ꯃꯦꯅꯔꯁꯤꯅ ꯈꯤꯇꯪ ꯀꯩꯅꯣ ꯇꯧꯕ ꯍꯣꯡꯗꯣꯛꯄ ꯃꯑꯣꯡꯅꯤꯀꯣ this is in the form of a plus b whole a minus b whole that is equal to a square plus a square minus b square ꯒꯤ ꯐꯣꯝ ꯇꯥꯔꯛꯀꯗꯣꯏꯅꯤ ꯃꯥꯏꯅꯁꯇ ꯇꯥꯔꯛꯀꯗꯣꯏꯅꯦ ꯁꯤ ꯂꯩꯕ ꯃꯥꯏꯅꯁꯁꯦ ꯍꯣꯔꯦꯟ ꯑꯃꯨꯛ ꯆꯦꯟꯖ ꯇꯧꯔꯛꯄ ꯌꯥꯏ ꯍꯥꯏꯕ ꯋꯥꯐꯝ ꯑꯃꯅꯤ ꯀꯣ ꯆꯦꯟꯖ ꯇꯧꯔꯛꯀꯅꯤ ꯕꯤꯀꯣꯖ ꯑꯣꯐ ꯁꯤꯗꯩꯗ minus root over -1 ꯂꯩꯔꯤꯑꯕ because there is minus ꯂꯩꯔꯤꯑꯕ -2 square p ꯍꯥꯏꯕ ꯋꯥꯐꯝ ꯅꯠꯇꯦ ꯃꯥꯏ ꯄꯋꯥꯔ ꯑꯃ ꯂꯩꯔꯤꯅꯤ root ꯑꯩꯅ power half ꯂꯩꯔꯤꯅꯦꯕ ꯑꯗꯨꯅ because of that power half that this power over here 2 cannot affect 2 cannot change the sign in front of that particular one 하이브니 as it is the sign remain as it is 하이브니 마이 몽두다 좀 ꯀꯩꯝꯇ ꯍꯣꯡꯗꯅ ꯂꯩꯍꯧꯒꯅꯤ ꯍꯥꯏꯕ ꯋꯥꯐꯝꯗꯨꯅꯦꯕꯀꯣ 4 ꯂꯩꯔꯦ 9 ꯂꯩꯔꯦ 13 ꯇꯥꯔꯦ ꯁꯨꯃꯥꯏꯅ ꯄꯨꯊꯣꯔꯛꯄꯁꯨ ꯌꯥꯏꯌꯦꯅ ꯍꯥꯏꯕ ꯋꯥꯅꯤ ꯃꯥꯒꯤ ꯁꯤꯃꯤꯂꯔ ꯃꯦꯅꯔꯗꯣ ꯑꯩꯈꯣꯏꯅ ꯃꯇꯥꯡꯁꯤꯗ ꯅꯩꯅꯕ ꯍꯥꯏꯕ ꯇꯥꯔꯦ ꯀꯣ ꯌꯥꯝ ꯂꯨꯁꯟꯅ ꯈꯟꯕ ꯌꯥꯗꯦ ꯀꯣ ꯌꯥꯝ ꯂꯨꯁꯟꯅ ꯈꯜꯂꯨꯅꯨ ꯃꯥꯒꯤ ꯉꯁꯥꯏ ꯍꯥꯏꯔꯛꯄ ꯇꯦꯛꯅꯤꯀꯦꯜ ꯄꯣꯏꯟꯁꯤꯡꯗꯨ ꯃꯥꯒꯤ ꯑꯜꯒꯣꯔꯤꯊꯝ ꯁ꯭ꯄꯦꯁꯦꯜꯂꯤ ꯑꯜꯒꯣꯔꯤꯊꯝ ꯌꯥꯝ ꯃꯨꯟꯅ ꯌꯦꯡꯉꯨ ꯃꯃꯥꯡꯗ ꯀꯔꯤ ꯍꯥꯏꯈꯤꯕꯒꯦ ꯍꯥꯏꯕ ꯃꯥꯒꯤ ꯋꯥꯔꯤꯗꯨ ꯀꯩꯅꯣ ꯇꯧꯔꯒ ꯏꯔꯛꯄꯅꯤꯅ ꯑꯩꯈꯣꯏꯒꯤ ꯂꯤꯇꯔꯦꯆꯔꯗꯁꯨ ꯃꯉꯥꯏꯅꯦꯀꯣ ꯂꯤꯇꯔꯦꯆꯔꯒꯤ ꯋꯥꯔꯤ ꯑꯃ ꯍꯥꯏꯕ ꯇꯥꯔꯦꯅꯦ ꯁ꯭ꯇꯣꯔꯤ ꯑꯃ ꯄ꯭ꯔꯣꯁ ꯑꯃ ꯑꯩꯈꯣꯏꯅ ꯂꯣꯏꯔꯝꯗꯥꯏꯗ ꯅꯠꯇ꯭ꯔꯒ ꯇꯪꯈꯥꯏꯗꯒꯤ ꯌꯥꯎꯈꯤ ꯇꯥꯔꯒꯗꯤ ꯍꯣꯔꯦꯟ ꯀꯣꯏꯁꯟ ꯍꯪꯉꯛꯄ ꯀꯥꯟꯗ ꯑꯩꯅ ꯌꯥꯍꯧꯗꯕ ꯄꯥꯔꯠꯇꯨꯗꯒꯤ ꯀꯣꯏꯁꯟꯗꯣ ꯍꯪꯉꯛ ꯇꯥꯔꯒꯗꯤ ꯑꯩꯅ ꯀꯩꯁꯨ ꯑꯟꯁꯔ ꯇꯧꯕ ꯉꯝꯃꯔꯣꯏꯕ ꯅꯠꯇ꯭ꯔꯥ ꯑꯩꯅ ꯑꯟꯁꯔ ꯇꯧꯕ ꯉꯝꯃꯔꯣꯏ ꯑꯗꯒꯤ ꯑꯟꯁꯔ ꯇꯧꯕ ꯉꯝꯗꯕꯁꯤ ꯀꯦꯁ ꯑꯅꯤ ꯁꯨꯏ ꯑꯃꯅ ꯀ꯭ꯂꯥꯁꯁꯤ ꯌꯥꯎꯅ ꯌꯥꯎꯅ ꯃꯃꯥꯡꯒꯤ ꯄꯥꯔꯠꯁꯗꯨꯁꯨ ꯇꯥꯅ ꯇꯥꯅ ꯑꯩꯈꯣꯏꯒꯤ ꯃꯥꯅ ꯄꯣꯏꯟꯁꯤꯡꯗꯨ ꯑꯃꯨꯛꯀ ꯀꯥꯎꯊꯣꯛꯈꯤꯕ ꯇꯥꯔꯒꯗꯤ ꯑꯟꯁꯔ ꯇꯧꯕ ꯉꯝꯃꯣꯏ ꯑꯗꯨꯁꯨ ꯅꯠꯇ꯭ꯔꯥ ꯑꯗ ꯑꯟꯁꯔ ꯇꯧꯕ ꯉꯝꯗꯕꯁꯤ ꯑꯩꯈꯣꯏꯅ ꯃꯔꯝ ꯑꯅꯤ ꯂꯩ ꯍꯥꯏꯕ ꯋꯥꯅꯤ ꯑꯃꯅ ꯈꯪꯉꯤꯕ ꯄꯣꯏꯟꯗꯨ ꯀꯥꯎꯈꯤꯕ ꯑꯗꯒꯤ ꯑꯃꯅ ꯄꯣꯏꯟꯗꯨ ꯌꯥꯍꯧꯗꯕꯗꯒꯤ ꯈꯪꯗꯕ ꯅꯠꯇ꯭ꯔꯥ ꯑꯗꯨꯃꯥꯏꯅ ꯇꯧꯗꯅ ꯅꯈꯣꯏ ꯅꯁꯥ ꯅꯊꯟꯗ ꯀꯔꯤꯒꯨꯝꯕꯗ ꯑꯟꯁꯔ ꯇꯧꯕ ꯉꯝꯃꯛꯇ꯭ꯔꯦꯅ ꯍꯥꯏꯕ ꯇꯥꯔꯒꯗꯤ ꯑꯩꯈꯣꯏꯅ ꯔꯤꯕꯦꯟ ꯇꯧꯒꯗꯕꯅꯤ ꯀꯔꯥꯏꯗꯅꯣꯅ ꯍꯥꯏꯗꯤ ꯑꯣꯖꯥꯅ ꯇꯥꯛꯈꯤꯕ ꯄꯔꯥꯗꯨ ꯑꯩꯅ ꯄꯣꯏꯟꯗꯨ ꯀꯥꯎꯊꯣꯛꯈꯤꯕꯅꯔ ꯅꯠꯇ꯭ꯔꯒ ꯀꯩꯅꯣ ꯇꯧꯕꯅꯔ ꯑꯩ ꯌꯥꯎꯍꯧꯗ꯭ꯔꯕ꯭ꯔꯥꯅ ꯍꯥꯏꯕꯅꯆꯤꯡꯕ ꯌꯥꯎꯍꯧꯗꯕꯒ ꯆꯞ ꯃꯥꯟꯅꯗꯣꯏꯅꯦꯕ ꯄꯣꯏꯟꯗꯨ ꯀꯅꯥꯒꯨꯝꯕꯅ ꯀꯥꯎꯊꯣꯛꯈꯤꯕ ꯇꯥꯔꯒꯗꯤ ꯀꯥꯎꯊꯣꯛꯈꯤꯕ ꯇꯥꯔꯒꯗꯤ ꯑꯃꯨꯛꯀ ꯅꯈꯣꯏꯅ ꯕꯦꯛ ꯇꯨ ꯕꯦꯁꯤꯛ ꯑꯅ ꯍꯥꯏꯔꯒ ꯕꯦꯛ ꯇꯨ ꯗ ꯀቨꯔ ꯄꯥꯔꯠ ꯑꯅ ꯍꯥꯏꯔꯒ ꯑꯃꯨꯛ ꯆꯠꯂꯒ ꯌꯦꯡꯉꯒ ꯈꯪꯒꯅꯤ ꯍꯥꯏꯕ ꯋꯥꯐꯝꯅꯤꯀꯣ ꯑꯗꯨꯗꯨꯅ ꯉꯁꯤꯒꯤꯗꯤ ꯁ꯭ꯋꯥꯏꯐꯥꯎ ꯇꯧꯁꯤ ꯀꯣ ꯑꯗꯨꯅ ꯅꯈꯣꯏ ꯍꯌꯦꯡ ꯁ꯭ꯀꯨꯜ ꯀꯥꯔꯀꯥꯟꯗ ꯑꯃꯨꯛ ꯄꯨꯂꯞ ꯃꯌꯥꯝ ꯊꯦꯡꯅꯔꯒ ꯑꯃꯨꯛ ꯐꯖꯅ ꯑꯃꯨꯛ ꯇꯧꯕ ꯑꯗꯨꯕꯨ ꯍꯧꯖꯤꯛꯇꯤ ꯏꯟꯃꯦꯠ ꯂꯥꯏꯐ ꯁ꯭ꯇꯥꯏꯜ ꯑꯣꯏꯅ ꯂꯩꯕꯅꯤꯅ ꯅꯈꯣꯏꯅ ꯃꯇꯝ ꯃꯥꯡꯍꯟꯗꯅ ꯑꯩꯈꯣꯏꯒꯤ ꯌꯥꯝ ꯐꯖꯅ ꯑꯩꯈꯣꯏꯒꯤ ꯂꯥꯏꯔꯤꯛꯁꯤꯒ ꯐꯦꯁ ꯇꯨ ꯐꯦꯁ ꯑꯣꯟꯁꯤꯟꯅꯔꯒ ꯂꯩꯕꯅ ꯍꯥꯏꯕꯅ ꯁ꯭ꯄꯦꯁꯦꯜꯂꯤ ꯃꯤꯒꯗꯤ ꯑꯣꯟꯁꯤꯟꯅꯕ ꯌꯥꯗꯦ ꯑꯣꯟꯁꯤꯟꯅꯕ ꯇꯥꯔꯒꯁꯨ 6 ꯐꯤꯠꯀꯤ ꯑꯩꯈꯣꯏ ꯐꯤꯖꯤꯀꯦꯜ ꯑꯣꯔ ꯁꯣꯁꯤꯌꯦꯜ ꯗꯤꯁꯇꯦꯟꯁ ꯑꯃ ꯊꯝꯗ꯭ꯔꯕꯗꯤ ꯀꯩꯅꯣꯅꯤ ꯚꯜꯅꯔꯦꯕꯜ ꯑꯣꯏꯔꯦ ꯑꯋꯥꯔ ꯂꯥꯏꯐ ꯏꯁ ꯚꯜꯅꯔꯦꯕꯜ ꯑꯋꯥꯔ ꯍꯦꯜꯊ ꯏꯁ ꯐ꯭ꯔꯖꯥꯏꯜ ꯍꯥꯏꯕ ꯇꯥꯔꯦꯀꯣ ꯑꯗꯨꯅ ꯅꯣꯠ ꯇꯨ ꯍꯦꯄꯟ ꯏꯟ ꯁꯆ ꯑꯦ ꯋꯦ ꯋꯤ ꯍꯦꯞ ꯇꯨ ꯀꯤꯞ ꯗ SOP ꯍꯥꯏꯕ ꯇꯥꯔꯦꯀꯣ ꯑꯗꯨ ꯐꯖꯅ ꯊꯝꯒꯗꯕꯅꯤ ꯀꯣ ꯁꯤꯐꯧ ꯇꯧꯔꯁꯤ ꯊꯦꯡꯛ ꯌꯨ ꯑꯣꯜ